What's happening, dogs? Mr. Allen here with a beefy one involving a quartic polynomial here. We have the function f of x equals 2x to the fourth minus 5x cubed minus 24x squared minus 7x plus 10 has zeros at x equals 5 and x equals negative 2. We want to find the remaining zeros of f of x. Well, first off, how many zeros should this function have? It's a quartic polynomial, degree of 4, so it should have 4 solutions. Not necessarily 4 unique solutions, because you can have like a multiplicity of 2 or a multiplicity of 4, whatever it could be, but 4 solutions is what we should get here. Now, we could have 4 imaginary solutions. You could have 4 real solutions. You could have a mix of 2 and 2. In this case, we know we at least have 2 real solutions. So how do we go about finding the other 2 solutions that are currently missing? We're going to use synthetic division to divide these guys out of my polynomial. So I'm going to divide out my 2 factors of x minus 5 and x plus 2 from this polynomial. And if I divide out 2 factors from a quartic, I'm left with a quadratic, which hopefully, fingers crossed, I can factor that quadratic. In worst case scenario, I'll use quadratic formula to get my 2 solutions. So we have a plan of action. Let's get after it. We're going to do synthetic division here. We can do that with these particular zeros. We don't have to use long division, which is nice. It doesn't matter which one you start with. I'll start with the 5. So I'm going to throw 5 in the box and then write down all my coefficients. Remember, with synthetic division and with long division, if I'm missing a term, I have to throw a 0 as a placeholder. This one has all of our terms. We're good. If, say, I was missing the negative 5x cubed, like that term wasn't there, I'd have a 0 in its place. All right? Draw my line. I'm going to drop the 2. 5 times 2 is 10. When I add these, I get 5. 5 times 5 is 25. When I add vertically, I get 1. 5 times 1 is 5. When I add, I get negative 2. 5 times negative 2 is negative 10. I get a remainder of 0. That's what should happen, right? This is a 0. My remainder should be 0 when I do synthetic division. Now I'm going to do synthetic division again with my negative 2 in the box and with these numbers right here, because this is really like 2x cubed plus 5x squared plus 1x minus 2. It's a cubic right now, right? So a little more synthetic division. Drop the 2. Negative 2 times 2 is negative 4. We add vertically. Multiply, negative 2. Add them, we get negative 1. Multiply, I get positive 2. And once again, I get a remainder of 0. So now I have 2x squared plus x minus 1. I can set this quadratic equal to 0, and I can solve for x. Is it factorable? Let's guess and check. Let's see. Even though we have a lead coefficient here, I'm going to guess and check because I got 2 and 1. There's only a couple combinations we can work with here. I got 2x, I've got x, right? I know it's going to be 1 and 1. One of those is going to be negative. One's going to be positive. Well, I want it to be positive x, so if I can get this to be positive 2x, and this to be negative 1x when multiplied, right? That's 2x, that's negative 1x, that adds to x. So it is factorable. And I can take my 2 factors, set them equal to 0, x plus 1 equals 0, and I'm going to get 2x equals 1, x equals positive 1/2. There's one of my other ones, and we have x equals negative 1 is my other. So there we go. Find the remaining zeros. Those are my remaining zeros. 1/2, negative 1. That's a bear of a problem right there, but synthetic division twice, doesn't matter which one you start with. The numbers will be a little bit different throughout the way, right? There we go. That's awesome. Dope. America. See you dogs later.